Hi there, welcome back. We're back to the Grundig Satellite 3400, and this is the part, or one of the parts that I've been looking forward to. It's actually the alignment, and this thing has got a lot of alignments that you can do. Needless to say, I'm probably doing stuff I don't really need to do, but I like to do it, so why not? This is supposed to be fun. The reception on this thing is actually very, very good, but, well, how good can it get? We'll only know when we try. And what I want to do is I want to follow the instructions on the alignment, figure out exactly what it is I need to do, try and follow their instructions as precisely as possible. Some of it will probably be improvising because, as I've mentioned before, some of these manuals are not very clear, and so it helps when you know what you're doing and why you're doing it. And as you'll see in this video, sometimes that is really needed. You need to know what it is you're trying to achieve, because sometimes the way they describe it just doesn't get you there. Anyway, first stage of the alignment is going to be the AM-IF alignment, specifically the 460 kilohertz. This radio has two IFs. The upper frequencies start with a 2 megahertz IF frequency, and then it converts down to 460, where it meets the signals coming through from the lower bands, like long wave, medium wave, shortwave 1 and shortwave 2. I'm going to focus on the 460 on this video. I hope it's interesting to you. If it is, stick around. We now come to the interesting bits. I want to do the AM alignment, the AM-IF alignment at least. They tell us to put the bandwidth switch to the narrow setting. So we want this as narrow as possible. And they say modulated frequency less than or equal to 1 kilohertz. That'll be the tone. I'm going to use 600 or whatever, even 1 kilohertz is fine. Let's follow the instructions. AM-IF alignment of 460 kilohertz. Needless to say, that's our IF frequency. And they give us the entire sequence and they tell us which filters we are aligning. You can see that here. Filter 17, 16, 15, and I did a quick look on the schematic and I think they've got it wrong. In fact, I know they've got it wrong here, because if I look at the German version, I can see here under the same item ZF filter 18. So we know they've got that wrong. So I've corrected that there. They tell us to connect the wobulator output to measuring point 502. Now what does that mean? Wobulator output. They used to use a wobulator which was a signal generator that swept the band around 460 kilohertz, and you would then pick it up and look at the curve on the scope, which I want to do as well, but we'll just look at this for now. So effectively they're telling us to connect the signal generator output to measuring point 502, and then they tell us that the indicator connection, or the measuring point, and here I'm going to use the scope, is a loose probe, or probe loose, on collector of transistor 502 or measuring point 503. This entire section is the same way. And then they tell us to adjust coil 1 for maximum. Let's have a look at the schematic and see what this is all about. We already figured out that this yellow board is the IF board for the 460 kilohertz. And we've got to look at the points they mentioned. Let's have a closer look at this. Here we go. We've got coil number 1. That's that one there. And they tell us to loosely connect the probe to measuring point 503, which is this one here. And it's the collector of transistor 502, which is this one here. And you can see that this is not a direct connection. It's actually sort of a capacitive link. And that's great. I'll show you what that looks like in a second. Now we're going to adjust this coil over here, coil 1, for a maximum at that point. Does that make sense? Well, yeah, it does, because this line here from the collector, if you follow this line back, you get to here. And here you get a tank circuit, which effectively becomes sort of the load, as it were, of this transistor. So whatever this transistor is doing, it's going to create the output at this point over here. So we're going to be measuring it there. And the signal is going to come from here, from this point over here. And they tell us to inject the signal at measuring point 502, which is here. In fact, they don't tell us to adjust 2 at all at this point because this is too close. Your injection point would affect the tuning of this transformer. So you cannot adjust this transformer with a device, an input device sitting over there. Okay, so we inject it in here and we measure there and we adjust there. Let's have a look at the board. We can actually see the board and that'll give us an idea of exactly what we're doing. We are opening this gate to 460 kilohertz. That is the frequency we want to allow to smoothly go through in that direction. Okay, let's look at the board. This over here is a drawing of the board that we have there on the front with the meters connected. Here's the meter over here. This is actually looking at it from the solder side, I believe, but it gives us a close idea of, we can actually relate or correlate the points here by looking at the components on the board itself. And we see some measuring points. Let's get a close-up. There's one there. You'll understand why I'm zooming in so much. They say that you loosely connect the probe to the collector of transistor 502. So you would go to collector 502, which is over here, and this line here is the same connection. Okay? How do you loosely connect a probe to that? Well, what you can do, and what I did with the Grundig 2100, is I soldered a wire up here and I wound another wire with screen, with insulation, just wound it a few turns and I got a capacitive coupling from there. They've gone one step further. They've actually created a pad here. You see this pad over here? This pad is not touching anything, but there is a test point on here. So what they're counting on is the capacitive link in this gap that we see over here between the measuring point and the actual trace that comes from the collector of transistor 502. So that's our measuring point. And if we go look a bit further back, we have measuring point 502 is here. So we have to inject the signal at this point over here. And now we have to find on the schematic or on the board itself what these where these points are. But just remember that we are going to inject the signal in here at 0.502. It's going to go through this. We're not interested in that one so much as that transformer over there. There's transformer 18. There's measuring point or adjustment point 1, the coil 1. That's the one we'll be adjusting. It's the one that sits by itself. There's one IF transformer, there's another one, and there's another one. It's the one that sits by itself. The measuring point is straight above it. And the injection point is this one here to the left. On the board, it's actually to the right of this top transformer. We've got our fairly usual setup. I've got the signal generator providing a 460 kilohertz carrier. I'm going to put the amplitude to the minimum, which is 1.4 millivolts RMS. There's no modulation at the moment, just the carrier, and I'm going to activate the output. The signal generator output comes into the input of this switched pi attenuator. I can attenuate by 3 dB, 6 dB, 12 dB, 24 dB, or the sum of any of those. And the antenna option is off here, and the output comes out there that goes to the radio. I've got a project that I did on this one, which I'll link above. Now the signal generator is connected to that point there, which is MP502. It's above those two IF transformers, as I mentioned. It's got a clip on there. And the measuring point is this one here, which is above that transformer, which is the one we're going to adjust. Okay? This is exactly as per the instructions. So now we're ready to switch everything on and see what we get. So now with the radio with medium wave selected, the bandwidth is on narrow. I've got the radio on. I've got the signals going in. And I've had to increase the amplitude to 10 millivolts RMS to see something on the scope. And it seems that that is still too low because I cannot see anything here on the strength meter. So I'm going to increase that again, 20 millivolts. As you can see, it's starting to go up there. Now, as long as I don't overdo it, let's leave it there at 60 millivolts on the meter. Remember, this thing is quite near the end, so it's actually been amplified quite a bit. You would not inject an RF signal of that size into the front of the radio, but let's see if we can peak it. And what we need to do is just to make that as high as possible. That's all they tell us to do. There was a peak. Oh, and something else I've noticed. You can actually use the tuning meter as an indication. Perfect. There's a peak. We've peaked that one. See how easy that was? No big deal. Let's see what else we need to do next. I love doing this. One down. Quite a lot to go. Now they tell us that we're going to peak IF filter 17 and 16, and we have to inject the signal at measuring point 501. We leave the detection section exactly where it was, and we peak 2 and 3 for maximum. So what exactly are we doing now? Let's have a look. So we've done that guy when we injected in here. Now they tell us to inject at 501, which is over here, and we have to adjust 2 and 3. So this makes sense. You've got 460 coming in. You injected it there, so you know that this last gate is open. This last filter is allowing that 460 kilohertz to get through. That's going to be the carrier signal that's going to bring all your audio information on it, amplitude modulated, of course, on the carrier. So you want to let that through. You want to block everything else out. And you injected it there just in case these guys were completely wonky. If these were completely closed down and you injected it here, you wouldn't hear anything over there. You wouldn't see anything over there, or there rather. So that's why you go from here, then you move back. And that's exactly what we're doing now. We're moving back to prior to this transistor. This transistor allows you to buffer the effect of the signal generator when it sends the signal into here. It goes through this coil unaltered. You do not adjust that one just yet. And now this transistor pushes that through this coil, which is then picked up and fed to that transistor by this coil. Okay, so you're going to adjust 2 and 3 for a maximum at 460 kilohertz again. Now all we need to do is to see where these guys are, 2 and 3, and we have to see where measuring point 501 is. All right, let's carry on. Well, 2 and 3 are here. 2 and 3, that's easy enough. Measuring point 502 was that one. We leave the detection or the scope probe on there. Now we've just got to find the injection point 501, which is down here. Okay, which is by that other transformer, which is sitting there on its lonesome, just above it on the left. So on the board, it'll be on the right. Let's carry on with this logically. We've got the injection point over here. There's a connection point over there. So I've got the injection going in there. Detection, or the scope probe, is still in the same place. We've got to adjust these two guys over here. And we can look on the scope or on the meter. Just a note, I've had to reduce the amplitude of the incoming signal to 2 millivolts RMS because otherwise it would just shoot off the scale. This is because there's another transistor stage over here which obviously amplifies the signal, and I wanted to get it, fairly low so I can see the effect of the adjustment. So let's try. Let's see what happens. Oh, wrong way. A little bit. Got a little bit there. I think that's a peak. I'm looking more at that meter than at the scope. That's a peak. We've done it. So we've done that one, and that one. And everything's run pretty nicely so far. Right, what's next? Well, we've done quite a bit so far. We've adjusted 1, 2, and 3. Now we need to adjust 4. But let's see what the instructions tell us. And before that, I just can't resist. I love painting my things in. They tell us that we are going to adjust filter 15 and 13 with K3 to K10 depressed. So we're going to delve into that the higher frequency shortwave board, and they tell us to inject on measuring point 202. We detect in the same place, and we adjust filter 4 and 6 for symmetry, and here for maximum and symmetry. Now, what are they talking about? Well, when we adjust it for a maximum, we've peaked it at 460 kilohertz, these three. We don't know what the shape of that passband is. In other words, if you've got 460 here, we've basically done that. The passband has been peaked, but we don't know what shape it is. What we actually want, something like this. With 460 slap bang in the middle there. Okay? And this will mean that the signals coming in at 460 will be optimally passed through, and then slightly lower and slightly higher, it'll start to curve down, and it has to start to curve down at exactly the same difference from 460. In other words, this point here, if we draw a line across here, I know this is getting confusing, but if we draw a line across here, if this is 464, we want this to be 456, so that this becomes a very smooth bell curve with 460 slap bang in the middle. We don't really know what we've done. We know that we've peaked it at 460, but this could mean anything. It could mean that we could have something like this. In other words, 460 could be there, and this thing is completely imbalanced in terms of symmetry, left and right of 460. So we don't want that. We want a nice bell curve. And we don't really know what curve we've got. But they do tell us here to start looking at the symmetry. So coil 4, we have to worry about symmetry. So let's see what that means. It means we have to inject on MP202. We have to select K3 to K10. And we have to measure in the same place. And it looks like we can now not avoid sweeping the frequency band. In other words, we're not going to send a 460 kilohertz signal only. We're going to send a signal from, say, 30 kilohertz below, say 430, to 30 kilohertz above, 490. And we're going to time the scope so that we can get that bandpass, that time, whatever time we set it to, on the screen, and it just sort of repeats itself. Okay? So we wanted to start at 460 down here. We wanted to go along, and as it gets closer to 460, we wanted to go up. And then at 460, we wanted to peak. And then we wanted to go down, and then it goes close to 0, and it gets to 490. Boom, and it comes back and does the whole thing again. That's what we wanted to do. That's what a wobulator does. That's why they mention a wobulator. It's a sweep generator. And we can do that very easily with the equipment we've got here. You don't need anything too fancy as long as you know what you're doing. So I'm going to set it up. I'm going to show you what I'm doing. And let's see what kind of sweep we get. Let's see what these adjustments, that one, and that one, have done to our curve. Have we got a nice bell curve centered on 460? Okay? But first of all, let me look at this. Where is MP202? If we look at the schematic, we are going to adjust this guy over here, this one, for symmetry. And they tell us to depress K3 to K10. So this switch moves to here, to the right. So the signal we're going to be getting is from the top here. If we follow that line and we go across, and we are in that board of ours that we've just cleaned the contacts on. Remember? Those gold contacts? So the signal comes in here, in here, in here, and there's 4. Okay, there is our coil number 4, adjustment 4, and where we're feeding it into is here. MP202, measuring point 202. So we're feeding in 460, or a sweep from 430 to 490, for example. Here, it's going through this transistor, and it should be coming out here optimally at 460. Now, why is that? Well, because actually this circuit back here, all the way back here, is producing something in the order of 2 meg. Well, actually, exactly 2 megs, 2 megahertz. This IF frequency that's coming through all these filters is at 2 megahertz. And when it hits here, it meets this transistor, which has a signal, which has a oscillator here. And this oscillator has to produce 2.46 megahertz. And this acts as a mixer, okay, which mixes the 2.46 with the 2. And what you get here, right, is you get the 2 megs, you get the 2.46 megs. You get the sum of the two, which is 4.46 megs, but you also get the difference of the two, which is 0.46 megs, which is 460 kilohertz. So you want to adjust this filter so that it only allows the 460 to get through. And because this is a simple mixer, if you feed in one of those frequencies, it'll get through. So if you feed in 460 here, you're getting the benefit of this isolation, this buffering. It buffers the effect of connecting a low impedance signal generator over here. And it still gets you the 460 to come out at this end, which you can then adjust this filter for. Okay. So that makes sense. Now we need to see where that MP202, we need to see where MP202 is. We need to see where coil 4 is. Okay. And we also need to see where coil, what is it? Sorry, that was 6, coil 4. So 4 and 6. That's what they tell us to do. That first one is for symmetry, I believe, and this one is maximum and symmetry, and we feed it into here. Now let's go and find out where this is. If we look at this board, this is that board that we clean the contacts on. It's the one at the back at the bottom. This is the capacitor that I couldn't swap out, remember? Because I couldn't remove this board. Hopefully it's not going to give us any trouble. We are looking for, oh, there we go, MP202, that's down there. And adjustment point 6 is over here. It's over here. So we'll be able to see it quite easily. But first of all, I'm going to inject a signal into here. And I'm going to adjust that coil on the other board to try and get symmetry. Okay, let's do it. First of all, I'm going to set this thing for sweep. And here we go. We're going to start at, say, 430. We'll start 30 below and we'll stop at 490 kilohertz. So we're starting 30 below and we're finishing 30 kilohertz above the IF frequency, the 460. We want a linear sweep, not a log. Okay, linear sweep. And I'm going to set the time to 28 milliseconds. I'll explain that when I show you the scope, the reason for that. Now, what's happening here is when I start the sweep, it is sending this out on channel 1 over there, but it's also sending a trigger signal, which is a square wave, which has a period of 28 milliseconds. So every time the sweep starts, it starts the square wave, goes across, comes down halfway, and it ends at the end of that time period. I'll show you that on the scope as well. I've taken that cover off that drum tuner unit, and I've connected. You see the red connection? There's a tag there. There's a contact point there. That is the point 202. So the signal's going in the right place. I have selected shortwave 3 to 10. Now I've got the scope picking up in the same position here. And if we look at the scope, we see a square wave. And the reason is I'm monitoring channel 2. That is channel 2 over there. And channel 2 has got coming into it that trigger signal coming out of the signal generator, which is active at the moment, okay? Now, if I change the time base for channel 2 at 2 milliseconds per division, I get that. And that is exactly one period of the square wave. Because there's 14 little blips on there, 14 gradicules at 2 milliseconds each. It's 28 milliseconds. That's why I set the time base or the time of the sweep for 28 milliseconds. Now, I'm going to switch on the radio, which is off at the moment, and I'm going to activate channel 1. And this is what we've got, which is kind of weird, right? What we are seeing here, if I adjust it, we are seeing the passband of our radio, of those filters starting at that measuring point 202, 102, all the way out to where we're measuring it from. And what we can see is that it's not a bell curve. Now, the best way to do this, because this isn't rectified, is I bring it down to there. Can get the amplitude to where we want it, say there. And what I know is that right in the middle, where that square wave is visible, that is 460 kilohertz. And the reason is I've got exactly 30 kilohertz below and I've got 30 kilohertz above. And I can do it even closer. So I can stop at 470 and I can start at 450. So now we're starting at 10 kilohertz below and we're going up past the 460 and we've got 10 kilohertz above. Is that right? 450 to 470. Now that is definitely not a bell curve. That's anything but a bell curve. So what I'm going to do now is I'm going to adjust these guys. They say we adjust this guy, this is that filter on there, for symmetry. Let's see what happens. Ah, well, that's symmetrical, but it's certainly not on 460. It's now on 4. Well, let me do something else. Let me take those gradicules and make them 2 kilohertz each. So I'm going to go from, I'm going to stop at, what is it? 2 is 14. 2 times 7, 14. So I'm going to stop at 474. Okay, and I'm going to start at 446. 446. I'm starting at 14 below and I'm ending it at 14 above. So each one of those vertical lines is 2 kilohertz. And now I can adjust the other guys. I'm going to play with these guys to try and get that more centered on 460. Now, can I do that? See what happens. No, that's just going down. What I'm going to try to do is I'm going to move the injection point back to here and see if I can't do it better there. Yep. Let me try that. I'm bringing the injection point back down here so I don't have to worry about that one, and I'm going to try it again. In fact, I'm going to take off the trigger and I'm going to redo this because I need to look at that guy, because I've got a sneaking suspicion that I've just gone crazy. Okay, let's try that just without the sweep. Let's just peek it again because I've messed with this. Okay, now I'll try the sweep. It's not too bad. Okay, I might be able to adjust this a little bit better now. Let's see. Let's come down to the middle. It's gone too far. Let's try the first one. That seems to be it. Let me try change the time to 14 milliseconds. 14 milliseconds, and now I have to do this. Does it look more symmetrical? Well, that's very symmetrical. That's slap bang on 460. Brilliant. I think that's working. Right, what I've done now is I've just set these three to create a symmetrical bell curve, which is pretty nice. Equal width at the top. So it's got quite a bit of band pass over there, which means we'll get some good fidelity, hopefully. Let me try again putting the signal on the back. Well, this is what we get. And that's definitely not symmetrical. So let's adjust this for symmetry. Well, that's sort of symmetrical, but it's now shifted. It's no longer on 460, it's on 461 or 2. That's not good. It's on 462. Why is that? Why would that shift? Try something. Let's put this on. Bro. Ha ha ha! Look at that. Look at that. I've just put this on. I've taken it off narrow and I've put it on the middle setting. And look at that. That's perfect. Slap bang in the middle. What happens if I put it on wide? Doesn't give me much more. And then I move that. That's no longer symmetrical. And that is actually the position I listen to it most. So I think what I'm going to do is I'm going to leave it there. I'm going to make it symmetrical there. And let's see what the one on the back looks like. Uh-oh. Yeah, the other one at the back is sealed. And in fact, it looks like it's sealed with more than wax. It's not the same as this. That one at the back is really difficult to get to. So, you know what? I'm going to leave it like this. I can always just readjust it to do this, okay? And to give this symmetry. if I want that. You know, maybe that'll sound better like that, but I doubt it. What I really want is a nice, see, that's giving me, it's making it too narrow. That is a perfectly symmetrical bell curve centered on 460. And I'm going to leave it like that for now. For now. I'm not going to mess with the back one. I'm going to assume that it's in good shape, because if I do mess with it and I mess it up, I won't be able to forgive myself. Sometimes just breaking the seal. This thing has got like, it's almost like it's a resin that someone's put on it. It's almost like they're telling me to leave it well enough alone. So, okay, let me see where we've got to. We have got this far. So we have done that one, and we have not done that one. So I'm going to leave that for now, and I'm not going to risk it. We can always come back to it later, and I have a problem accepting that, but I'm just going to have to learn to live with it. Okay? All right, now, what do we need to do? Filter 14 with medium wave depressed, entry point 401. Where is that? For maximum and symmetry. So now we're going back to, let's have a look at the schematic again, 401, and it's filter 14. Because it says medium wave depressed, it means we're no longer taking the signal from the top here. We're taking it from here. So let's follow this guy back. Comes to here. Here we go. Filter 14. And it's 0.401. So that's it there. We have to adjust. That's 14.5. Yep. And again, we're using the transistor as a buffer, and we're feeding it into there, which is just before the transistor, which is a safe place to feed it in. Now let's try and find this. I think this is on that main board. Okay, it's on this board, and I'm looking for filter. Good Lord, how are we going to find this? I know I'm on the right board because all the components start with 400. This is one way of knowing that you're on a particular board. Some boards start with 4, we had 5s, we had 6s, we have 8s. So I'm looking for an IF transformer. 14, is that it? Yeah, it's here. Now I've just got to find the insertion point. I've got to look at the schematic again. And it's just on the base of transistor 402. So there's filter 14. Where's transistor 402? There's transistor 402. Where's the base? There's the base. It could be anywhere here. Here it is. Bloody hell. That took test point 401. How did I find it? Okay, transistor 402 is here. I went to the base. Here's the base. Followed this up. Not there. Followed it up to there. Then followed that teal blue line underneath, all the way across here, all the way across here. Boom, there it is. Okay, now it's a question of finding it on there, and then we'll know we have to adjust this guy. Okay, let me look for that. All right, found it. The injection point is on one of those switches. It's actually on the K2 switch, and you count the number of pins down. I can't remember the letter. Anyway, injection point is there, and the one we have to adjust is this guy over here, yellow one. And what we see on the screen is this, which is not too bad. Now this is with that setting, the bandwidth setting in the middle. Let's see if I can perfect this. No. Sort of brings it down, doesn't it? You know what? I think that other one would have corrected for this. Yeah, you mustn't try and be too clever. Hang on. Let's see what happens if I do that. Oh, double hump. That's on narrow. No, it's never going to correct that. Put it back in the middle. Let's do the best I can on here. If I take it down too far, just not good. I wonder. See, that one's good. The other one's got nothing to do with this one. Oh, I've got some real noise on here. What is it? Something switched on in my bench. Bloody hell. Okay, I'm going to do this. I'm going to do that. It's a little bit lopsided to the one side, but I'm going to leave it at that. What happens if I put it on narrow? Same story as the other one. So that's what I'm going to get. And I'm going to be happy with it, and I'm going to learn to live with it. I think. We'll see. By the way, if you guys know anything I don't know about this alignment, we're talking about the AM-IF alignment so far, please let me know, because I am a little bit baffled with that shifting of the center frequency, and I really would like to know if I'm doing something completely stupid here. But it makes sense to me. This is the band or the bandwidth I'm going to be listening to it most on, and I've now taken the higher frequency bands and I've given it a nice bell curve, and I've taken the lower frequency bands, medium wave, long wave, short wave, and I've done the same. So as far as I'm concerned, that's done. In the interest of completeness, I have a correction to make. Remember I said this guy was completely jammed up with lacquer of sorts, and that I thought that was the adjustment point 6. It wasn't. 6 is over here. It's a normal IF transformer, and it certainly isn't jammed up. That 7 is for the 2.46 megahertz oscillator. So we'll forget that for now. I was just playing around and I noticed my error. I've actually managed to remove that filling. I haven't made this adjustment yet. I just wanted to make everything clear. But I did try and adjust this one, and it made absolutely no difference to the shape of that curve. So it's being left as we saw it. So I think that's enough for today. We've done the IF alignment of the 460 kilohertz intermediate frequency. I think I'm quite happy with the result. I'll be testing it later and seeing whether anything has changed. I probably find that not much has changed, because this thing was pretty well aligned to start off with. But as I said at the introduction, you're never happy till you know that you've squeezed as much as you can out of this, out of the settings. So that's it for now. I hope you've enjoyed the video. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links at the end of the video and in the description below. Thanks for watching. Bye for now, and stay safe.